how is going? So this video I'm going to talk about another interview question for engineering with Java platform. If you don't know about this platform is the one that I created for covering the real world interview use cases. The problem like this, which are focusing on the real world engineering design and not just like a plain lead code style question. Because you would be surprised to know that a lot of companies they interview based on the real world understanding and not just some like numbers and some memorized logic or algorithms like we expect from the lead code. I mean, there are companies that do those kind of interviews mainly to filter the candidates, but I have seen like many companies now focus these kind of interviews and try to evaluate the knowledge of the candidate. So yeah, I try to cover these kind of question on engineering with Java platform. Just to give you a high overview, so we have like 66 plus interview question at this point. Many of them are free. They are paid content as well. So feel free to explore and see what fits you. And if you like it, consider becoming paid subscriber. Subscription is pretty cheap. If it's not because of purchase parity, DM me and I'll look into it. But yeah, I really hope you like the content. If you don't, again, DM me. I'll try to improve the platform. Who am I? I am Suraj. I work as tech lead at PayPal. Spent 4 years there. Before that, I spent 6 years in company called Rakuten. I have worked in different countries like Japan, US, and currently I'm based out of Canada. So yeah, if you have any, if you need any help about the job market, engineering questions, moving abroad, and so on, if I can answer that question, I'll definitely will do. So with that, let's move to the question. So the question is Spring Boot interview connection pool exhaustion. Now from the title, it seems like this is related to the DB connection getting exhausted. And let's read the scenario. So we are working on a Spring Boot based user activity service for high traffic SaaS application. Every time user logs in, system updates the last login timestamp in the Postgres database. Now, during the peak hours, production starts showing request stuck waiting for the database connection. Now, Hikari connection pool is the library that very popular for managing the connection pool with the database. So, Hikari pool connection pool, exhaustion error, suddenly spike in API latencies, and no obvious slow queries. Now this is interesting because many a time you will think that if the latency shot up, this might be due to like if we change some query or DB data has changed, or there's index that now is not efficient anymore, those kind of things. So this something is very good to know about that. This is not related to slow query, so they're just giving us that hint. After the investigation, they're saying that this is a piece of code that is suspicious. Our goal is to read through it and try to understand if we can get any signal about what can be wrong. And now the what can be wrong, it depends on as well the things that we have seen in the metrics like request stuck waiting for the database connection, Hikari connection pool exhaustion error, and sudden spike in the API latency. And then we talked about no obvious SQL queries. So what do we understand with that? So request stuck waiting for database connection, meaning that database connection was not available for the user request. And then connection pool exhaustion error. So we were getting the that connection pool. There's no connection available, and because of that, it seems like a lot of requests got the additional latency while waiting for the connection. So this checks out. Seems like there's something that going on which making the existing DB connection to take longer time, and hence the consuming time on that connection and making sure that basically makes the other request wait on the connection. So let's see what if we can find out some hint from the code. So what we are doing in this service, so we have this JDBC template trying to update the login for the IDs. We iterate over each user, try to update each user's last login and the Yeah, last login for that user's ID with the current timestamp. And then there is a simulating expensive processing. So there's a trying to do some audit logging, remote call, etc. Which with the thread slip. So basically there is some expensive call going on there, which is taking time. And then we have the other method called async update, which is trying to again execute the same query, but this is another method which is doing like async update logic. So these are the two methods. We'll get back to it again, but I think we understood the scope of work here. Let's see the question. What are the problems with the implementation? How do they contribute to connection pool exhaustion? Very important thing, if you understood it from the logic or not, but if you're not, it's fine. I think one of the major problem I see is that when you have the transactional annotation, what does it do? Basically, when you enter this block, it starts the begin commit. Sorry, it start with the begin command, and then you have like a set of operation that you're doing, um, and then it commit the transaction at the end of the block. So think of it like you start a transaction with the begin multiple sequels that you want to run atomically, and then at the end, as soon as you as soon as you exit the block, the all the statement get committed to the database. So uh, now if you see here, what are we doing? We are trying to update the DB, which is correct. But if you see, we are also trying to do some expensive processing like audit trail, remote call, and so on. Now, this has nothing to do with the DB, right? Like, why would you do something in a transaction that does not belongs to the database? Do you get what I'm saying? Like, your transactionality should only cover the code that is interacting with the database and not something that you are connecting with the third party system like audit trailing and the remote call. Why? Because they won't be atomic anyway, right? Like the transactionality only guaranteed on the database side and not for the other system. So the best practice here is that whenever you are doing transactionality, make sure your transaction is small, like only for the part where you are writing or updating to the DB. Also, you shouldn't have a transaction for the read requests don't require transactionality. So only for the writes and update you should have transactional block transaction annotation and keep it smaller. And then the other block like async update, what do we think about that? Now here we have async, means like this method will run as not part of like a request thread, but there will be separate thread invoked and it will be done in the background, so your request thread doesn't get blocked. So when the request comes, it fires it and just forgets it. Now there's another thread that handles this and then does the work. With the async, we would think like, okay, so yeah, we have offloaded the work to the different thread. Now we are good, but this is not good because even if you offload this to async thread, it's still transactional. You are still running that on the DB side. So there's a limited number of connection pool that is available on the database side. So just offloading to a different thread doesn't solve the problem. Yeah, it solves one part of the problem, like you can have more requests, but again, you are limited by the DB resources. So how would you circumvent that? That's the problem here. So just marking it async won't cut it here. So those two things I see a problem. And yeah, I think transactional wraps, multiple database updates, and then no database processing. So this causes single connection to be held for several seconds. Under the load, active connection increases faster and then they release, which is basically exhausting the pool. Similar for the async update, it would feel like, yeah, we are trying to offload, but async thread can scale, but not the database connection. So this is kind of overwhelming the connection pool. So that's what the problem seems like here, that we have we are blocking the transactionality for a very long time and more than what we need. So that's not a good, that's not good. So the next question is, how do we fix this? As I said, we should keep the transaction short and deterministic. The part for which we really need the transaction, it's an expensive resource. So whenever you need it, for example, you need it for delete, update, write methods, open the transaction. If possible, do the bulk operation, in the batches and then just close it. Don't keep it open for like whole request, which is it's a waste of the resource. Now, again, yeah, never mix the slow logic with the database transaction. Avoid async on blocking JDBC operation because that doesn't give you anything better there. And the last point, as I also spoke earlier, the batch updates. So whenever you can do the batch operations together, because that puts less like first of all you will be saving on your round trips because every round trip to DB counts for the latency, right? So just doing one query, and DBs are also optimized on doing like a batch operations. So consider doing that. So this is the modified query. We're trying to do batch update. We try to um, take a batch size of 500 here, uh, and then doing the update for those 500 users. And yeah, that's the modified version we should be following. And then the one more thing here is that this method that we have here is part of the repository. So in the service we just keep it when we need it, like we want to just update at that time, we just open the transaction, because the transaction annotation, if you see, it's here on the repository, and the service just calls it, the short transaction, done. And then whatever we are doing for audit, logging and anything, those are part of like outside the transaction. So yeah, that will not basically use the database connection efficiently, do the work, return immediately, so that you can, the other requests can use it. So yeah, whenever there is sacred resources like database connection, request thread, we need to be very careful about how we are using it, so that we don't abuse them. We talked about single update with the async. Like we don't need async here because we even if we offload the request thread, we're still bound by database call. Doesn't give us much there. We can keep it synchronous. And yeah, I mean, if possible, can use batching. If it's not, then yeah, single update is fine. Just let it be synchronous. With this, like you have predictability, like you can have back pressure from the DB pool. So a good choice, I would say. So that's the thing about this interview question. I hope you learned a thing or two. This is seems like very liked by you other readers. So definitely do check out. As I said, there are more questions here on the homepage. If you go and look at the Java Spring Boot real world question, a lot of questions there. I keep posting at least one or two in a week, and I, as I said, I plan to finish 100 questions. There's also this interview question tab that you can click, and you can see the list of question in the tabular format. I mean, this is Substack, has a very bad design, so sorry about that. But like, yeah, I try to pull this in a tabular format with the different statuses here, like published, in progress. There are multiple questions. Try to read them. It may help you prepare for interview, or even like in general, it will make you a better engineer. Because how do I come up with this question? Basically, I try to like remember the thing that I've seen working on a project, and then try to just create a note out of it, and then I try to create a full scenario for others to help them. So that's how I create this question. This is purely from my experience. Whatever I'll do in work, if I see that it's worth creating question out of it, I just do it. So mostly the experience part that drives me here to write this question. So yeah, that's it for this video. If you have any question, as I said, just DM me. And I have my YouTube channel also. So please uh, make sure to subscribe and um, follow along with my videos in future. All right, thank you so much for your time. I'll see you in the next one. Bye.